Hi guys, Mr. Turville here, and we're talking about graphing absolute value equations. That's Module 2, Section 1 in our current book, but that's graphing absolute value equations. We have already talked about graphing functions in general and translations of them, and so we're going to use these principles even further as we talk about graphing absolute value equations. Okay, I'm going to go over some basic stuff, and then we'll do some examples. Okay. So let's get this guy over here where we can see a little better. Just a refresher, what are absolute value functions? Well, remember, an absolute value is when you're talking about the positive value or the distance from zero. So when we say the absolute value of -5 is positive 5, we're saying it's 5 units from zero. So so that's how far from zero it is, whether it's positive or negative. That is what absolute value is. And so that can end up giving us a couple different things. And the graph for an absolute value is just a V. It's just the diagonal line normally and then turn into a V kind of deal. That's the parent function. Um, and so when we're talking about the vertex form of the absolute value, that's this guy right here. And now up to this point, we really haven't been worried about this 1 over B piece, haven't we? We really haven't. Before we go any further, though, let's do a quick refresher. We've talked about big stuff here, right? Big stuff when it deals with transformations. And what do we always say about that? Get me out of the way. Transformations is when something's on the outside, we're talking about up and down. So in this case, the K back over here on the backside, it's kind of weird to see there, that goes up and down. It just shifts it. And that V goes up, down, like that. Yeah. But over here, what about this A? It's also on the outside. Does it do the same thing? No, no, no. What it does is it pulls it up, which makes it more narrow, or it compresses it down vertically. Ow, that stretches. Okay, but that's okay. It stretches it wider, but it's still a vertical concept, whether you're stretching, compressing vertically, or you're just straight moving it up or down vertically. If it's outside, it's talking about up and down. Okay. And if it's inside, we're talking about left and right. That's where the X is. See, there's an X inside the absolute values. That's X, and X always goes left and right. But because of this minus in front of the H, it always seems to go backwards. Okay, it's opposite of what it seems. And we're going to introduce this 1 over B, and that's going to be dealing with this idea of stretching and compressing horizontally. Stretching, compressing horizontally, which again is going to be backwards of what you kind of think because it's 1 over B. And we're going to go over some examples to kind of help with that idea. Slide me back up here out of the way over there. And let's go to here. So in this case, our first example they have here, okay, our parent function, let me graph in our parent function. So just to do a reminder, what is the parent function for the absolute value? It's just got that slope of 1, right? And -1 there. So that's the parent function of the absolute value. So kind of important to have that. So what we've done is we've gone down to, okay, so we've gone down 2, and this is going by 2s, right? So it's gone down 2, and then it's going to go not left 5, but right 5. So you can see it went 2, 4, and then 1 more. Okay, so it's gone right 5. So that's what's happened to its vertex. And you notice it's more narrow than it was before, right? Because this 4 on the outside means it's been vertically stretched by a factor of 4. That's how they say that. So basically, they've gone a rise 4, run 1. Rise 4, run 1. So that is what's going on here with that guy there. So let's jump to some of the examples that you're actually going to be doing as part of the assignment. Okay, let me jump out of that. And theoretically, this should be it right there. All right, good enough. All right. So here's our first one here. I'm not going to kind of walk through it beginning to end. Um, ask you some questions. We have 6 times the absolute value of x minus 5. It says the graph of the function compared to the parent function shifts. 1 through 8, and then left to right. So they're talking about, so if they're talking about left and right, that means they're talking about the inside, aren't they? It has to be the inside if they're talking left and right. So this 5, so we're talking about the 5, has to be that. And it's -5, so it would think left, but remember it's backwards because that negative sign, so it's really going to be right. And then over here it says the graph then is vertically, because that 6 is on the outside, it's got to be an up and down idea, stretched by a factor of 6. Okay, so then we come down here and look at some of these choices. Which one of these choices match? Okay, well, it says it was shifted 5 units to the right. So how many of these were shifted 5 units to the right? Well, it looks like C and D are the only two choices that were shifted to the right at all, right? Uh-oh, hold on a second. Well, C was shifted 5 units to the right. D was shifted 6 units to the right. They're trying to trick you. So C is the only possibility in this case. Now, sometimes, because they all have the same shape, sometimes they'll give you two of them that kind of look that would work, but one has been stretched and one has been compressed, and you got to pick which one. Okay. And see, oh, we did pretty good. So let's go to the next one here. Slide up. Number 2. That's very much the same, except you got this negative in front. What's that going to end up doing it? That's going to make it flip over. So we already know, as far as the graphs are concerned, A and B are the only two possibilities. A was shifted down 4 units and B was shifted up 4 units. So according to our equation, it's got a +4. So that means it's been shifted up 4. So we already know that B is the correct answer for this one. So it was shifted. See, what's it asking here? Left or right? So it's going to be left 1. Right. So type in a 1 there, and it was vertically stretched. Yeah, that's outside. Vertically stretched by a factor of 2, and then it was reflected across the x-axis and up 4 units. Okay, see how we did? See if we can get this down far enough where we can see the check answer. Uh-oh, what did we do wrong? Oh, it it canceled our selection. All right, there we go. So somehow or another that got canceled out. It wasn't there when we went to go hit check. Got to have that. All right, now this one's a little different. This is the very first one you've probably seen with horizontal in it. Okay, so I don't mess with horizontal. I just don't. What I do is I think, if that was vertical, what would happen? And then I said, well, it's not, so it's got to be the reverse. So I get real good at one thing and then know that everything else is just the opposite. So since 7/5 is inside, okay, so if it was outside, so let's just pretend for just a moment, if it was outside, you'd be going up 7/5, right? You'd be rising 7 and running 5. Now, is that rising more or running more? It's rising more. So if that was on the outside, it'd be vertical stretch and make it be getting skinnier, right? So what's the opposite of stretch? Compress, right? So it's going to be a horizontal compression. Okay, again, if it had been on the outside, we would call it a vertical stretch. Okay, but the opposite of the vertical stretch is the opposite of vertical is what? Horizontal. The opposite of stretch is compress. So I can either stretch it this way to make it skinny, or I can push it this way to make it skinnier, right? And so this is a horizontal compression, and you even notice that it's got the 5/6 because that 1/b thing ended up flipping it over. Okay. And then the rest of it's what you already know how to do. But that's how I kind of work with it is I just pretend like it was on the outside, ask myself the question, hey, 7/5, it's getting taller, isn't it? It's getting taller. So how can I make that happen? And in this case, you could just do it this way as well. Inside, it's getting taller. How can I do horizontal to make taller? I have to squish it this way to make it taller in horizontal. Okay. So, but the idea is you rising more or running more, and how does that end up going together? Put that there. So again, don't over stress when it comes to uh, horizontal stuff. Try to figure it out. If worst comes to worst, stick it in the calculator, see what happens. Okay, see if it got compressed to make it skinny, and horizontal stretch to make it wider. So like this one here, it's rising 4 and running 7. So it's getting wider, right? Well, how do you do things this way to make them wider? Well, you're going to stretch it this way, right? So it'll be a horizontal stretch. And now some people get messed up because you're saying, well, that's 4/7 and that's 7/4. Remember, the that's going because that 1/b is going to end up flipping that thing over. So A is good. And then and so it's to the right 5 and up 2. So up 5. I think it's right. Yeah, right 5 and up 2. Is that the trying to slide back and forth? Yeah, up 2. And which one of these graphs go right 5 and up 2? And remember, the number in front is positive, so it's got to open up. So A is definitely wrong. D is definitely wrong. C's moved to the right, B moved to the left, so C is my only choice. That's anywhere reasonable. Oops, it didn't like something we did. Let's see what's here. C, I would definitely say that was 5 to the right. Oh, did it not keep my answer again? Huh, strange. All right, so let's jump over to some other things. I bet you that you're going to be more interested in me doing with you here. Let's go over to 13. All right, 13. Okay, now this one's a little different. So we're trying to write an equation from the picture. So what do you need to write an equation? So if you haven't figured this out yet, what do you need to write an equation? You need the A value, the H value, the K. So you need the vertex and then the A, which actually controls the shape. Those are the three things you need to write a model. Or a equation, right? That's what you need. Now, see how much we can figure out from the picture here. Well, our vertex in this example is is it going by? It's going by ones. It looks like so. 1, 2, 3, 4, 5, 6. 1, 2, 3. So the vertex is 6, 3. So they have given our H and K to us, right? So we got H and K. Now, can we figure out A? Well, one thing we could do is we could find a point along the graph and plug it in for x and our y, and then that we could solve it for the a. And you're going to have to do that for one of these problems, but this one I don't think so. Let's just find a good point where it crosses. That looks like a good point right there. That's a good point. So what is the slope between these two? So we got, let me put this in red. So we got 2 up and down and 7. So it's 6 plus 1, that's 7. Okay. So our A is going to be equal to 2/7. Is that correct? Almost. But remember, this is opening down. So it has to be negative to open down. So now we got our A, we got our H, and we got our K. So we're just going to plug those three things in, put those guys up here, and you got your equation. All right. I'll tell you what, I'm even going to write it out for you. So it's negative 2/7. And this section, they aren't being silly about how you putting that function notation in there. It's just going to be straight. With what we got here, H we said was 6, close absolute value sign, and then plus 3. And so that is your model, okay? Just getting the information from the graph. Let's see here. The next one on my list, I think we want to talk about was 14 and then maybe some 16. So what about 14? All right. So this is talking about a rainstorm as it drizzles and builds up to the rain. So let's talk about some things. So we first of all, here's our equation. So it opens, the negative front means it opens down. So with that information, what do we know? Good grief, I still do not know why it makes it so big. But there we go. With knowing that it opens down, that makes this choice not possible. It makes this choice not possible. There's something else I want to mention to you here. Is it ever going to be below the axis here? That part just doesn't make any sense, does it? You know, it's going to quit raining. It's going to quit raining. It's not going to keep going to the negative amount of rain. And so this stuff right here just would never happen. Okay, not in this scenario, right? Not in this real world example. And so it's talking about when it started raining. Now, what does this bottom? What does this stand for? That says T, time. Is there any such thing as negative time? No, there's no such thing as negative time. So this isn't even a thing. That is unless you have a TARDIS and you have what's called a time machine and you can go backwards. But those things don't exist in the real world. That's fiction, right? Nice, fun science fiction, but not in the real world. So since there aren't any negative time, so this guy has to be our answer here. And so, but they do talk about a couple of things here. Can you see what's going on down there? No, it does talk about, hey, when does it, how long does it rain? Well, it sure looks like it's from 0 to 8, and then it rains the hardest at 4, right? At 4 hours into it, or 4 minutes. I guess it's 4 hours probably. That's the deal with that one. Let's see, your assignment was 13, 14, 16, 18, 19. I think we're going to look at 16 real quickly here. I think the other ones are going to be just fine. Oh, yeah, here we go. So this is nice. A little dilly, isn't it? At first, it seems pretty easy, but they're going to put a twist on you. So it's a sunlight. Oh, good, good sunlight. So sunlight's going to come down and reflect up, and it's going to reflect at 3.50. Well, this is definitely not. Let's see if I can get this to play. Nope. That's definitely not at positive 3.0. So this is a maybe. This is possible, right? This is a possible. Okay. And I'm going to come back down here. And so B is possible, and so is C. So B and C are both possible. Okay. Um, according to that vertex. Now it says it hits Sam at the point 6.5 comma 4. Okay, and it says round to decimal places. So what I'm going to have to do, okay, what I'm going to have to do is simply this: is I'm going to have to put 3.5 in for H, 0 for K, and then 6.5 in for the X, and 4 for the Y. And so that'll get it all down to just one variable, and I can solve for A. And then that'll help me know which of these is the correct equation. Now, there is another possibility, okay? What if I was to figure out, we know it's B or C, correct? We've already established it's got to be B or C. What if I got the slope from this picture? What if I was able to get the slope from this picture? Well, that's a big what if, because apparently I can't. It doesn't have a really good spot, does it? Let's see if this other one works well with us. Well, we might. Well, what you could do is that this looks like it might have a decent spot there, right here at 5. So we could get the slope of from this point to the 5 and 5 comma 2, that point there, and we could use that slope, okay? And then we could plug it in to our A. And so whatever that is, and check it, and then see which one of these is going to actually go through the point 6.5 comma 4. Well, hold on a second. We don't have to put all that in, do we? But that would be a good way to do it. But since we're looking at this, which one of these guys actually goes? 6.5. Well, that doesn't go to 4 at all, does it? Okay. And then we go over 6, 4.5. So it has to be C. Oh, goodness. I went around the world a little bit because I knew that other questions you'd had to do it that way. But no, not in this. Oh, no, there is a problem. There is a problem. What is that? You are going to have to do that work to figure out that little dude right there. Um, so we've gone over examples about that before. You got your example button. Use those to your advantage. So we know it's C, kind of thing, and so we can use these 2 points to find out what the exact day is. If it was up to me, I would probably try to put in the hoping that this is exactly the right and try that one first. If the computer doesn't like it, then you're going to have to go back and calculate it for sure. I tried at least once, just calculate. I'm just doing the rise and run off of that, dude. All right. Well, that's 2.1 graphing absolute values. Walking through a few of those examples there. Hope that is helpful. Need any questions? Let me know.